right, we made it through chapters 1 and 2. Now we're going to get into chapter 3, which is wiring methods and materials. Chapter 3 is really the nuts and bolts, the physical products, the boxes, the conduits, the cables. So for people in the field, chapter 3 is something that we spend a lot of time in. If we're in the design community, maybe it's not quite as much time spent in chapter 3 as it is in some of the other chapters. But Article 300 gives us the general requirements for wiring methods and materials. So Article 300 really kind of sets some baseline requirements for all of Chapter 3. And of course, these apply throughout the code, but mainly for things that could be located throughout Chapter 3. And instead of repeating those requirements in all the different articles, we just kind of have a general requirements article, which is Article 300. Now remember, for the 2023 code, we tried to isolate any medium voltage requirements out of the articles and put them in their own new location. So Article 300 now applies to 1,000 volts AC or 1,500 volts DC and less, and higher voltages would be found in Article 305. So with that said, let's go ahead and get into Article 300, General Requirements for Wiring Methods and Materials. The first change that we're going to talk about is in 300.4, Protection Against Physical Damage. And quite a few things happened here. Protection requirements for RTRC conduit were relaxed. That's reinforced thermosetting resin conduit, fiberglass conduit. The rules for metal corrugated roof decking were clarified. And the installation of protective fittings was revised as well. All right, now 300.4 starts out with a general requirement, and this sometimes gets overlooked because when we have a big section in the code like 300.4, 300.4 has subsections A, I think through G at least, maybe even H. And when we have a big section of the code like that, it's easy to not read the actual overall opening requirement, the charging language, and instead to just jump into the A or the B or the C that you think applies to you. But 300.4, before we get to A and before we get to B, it has a general requirement that is a requirement. It says, listen, wherever subject to physical damage, conductors, raceways, and cables have to be protected. Now, A through G, or whatever it is going to give us some specific ways to satisfy that requirement, but 300.4 is a requirement in and of itself. We have to protect things if they're subject to physical damage. Now, A talks specifically about bored holes through wood framing members. So holes for wiring in wood framing members must be at least 1.25 inches from the edge of the stud, rafter, or similar, or the hole has to be covered with a steel plate that's at least a 1/16 inch thick. Now, this may not seem like a change, and you know, at first glance, it probably isn't. The change here is it used to say that we needed to be at least 1.25 inches from the face of the stud. Now it says from the edge of the stud. And I think in most instances, that's probably not really going to make a difference. When we look at this picture here, is this wiring, you know, where's the face of the stud? Well, I think the face of the stud is probably the part that we apply the drywall to. So it needs to be at least 1.25 inches from that, or we'd have to install a nail plate. But that's not my only concern. What about this hole in this location? Is that within 1.25 inches of the face of the stud? I don't know. It begs the question, what is the face of a stud? And does it matter? Maybe a better word instead of face would be edge. So that's what they did. Now it's very clear that this installation is non-compliant. If I'm concerned about the drywall guy running drywall screws through my cable, I need to be equally concerned about the stucco installers putting staples through the back of my cable, through the back of the stud. So it doesn't matter if it's the front or back or face or whatever. Now it says the edge of the stud, which again I think is a nice clarification. We also tweaked the exception here to say that nail plates are not required to protect rigid metal conduit, IMC, PVC, now RTRC, or EMT. I don't think anyone's saying that PVC or fiberglass conduit are equivalent to rigid IMC or EMT. I mean, they're obviously not. They're not steel. But are they strong enough that we don't need to nail plate them? That's the concern here. That's the question. Now, what the code used to say and when I say used to, I mean a couple of code cycles back, it used to say you did not need nail plates for rigid, non-metallic conduit. Well, if you've been playing this game for a while, you might remember when we called PVC conduit rigid non-metallic conduit. That was the name. When you went to Article 352, it was titled rigid non-metallic conduit. That hasn't been the case for quite some time because there's more than just one type of non-metallic conduit that is rigid in nature. Fiberglass is rigid and it's non-metallic. So to call something rigid non-metallic conduit doesn't really mean anything. Yet in this section of the code, that's exactly what we used to say in this section. So we just kind of cleaned up this section to use the terms that we've been using for the last 10 or 12 years in the code. So again, nail plates are not required to protect rigid or IMC or PVC or reinforced thermosetting resin conduit or EMT. We still have the same exception that says nail plates thinner than 1/16 of an inch are also allowed if they're listed and marked. Nail plates do not have to be listed. That's not a requirement. You can use any piece of metal that's 1/16 of an inch thick. I should say any piece of steel. So any piece of steel that's at least 1/16 of an inch thick. If you buy the listed nail plates, then we know that they've passed whatever tests the UL standard has in place for them, and we know that they're going to be strong enough to stop nails and screws. Now, here we've got a drywall screw going through a listed nail plate. I mean, look, I'm not going to tell you that this thing is a bulletproof vest. If you try hard enough with your drill, I'm sure you can get a screw through here. But it should be hard enough that the drywall contractor realizes he's hitting a nail plate and he stops. So if you have thinner than 1/16 of an inch and it still passes the tests set forth in the product standard, well, then you can get it listed. The thinner ones are made out of case-hardened steel, and yeah, they're not 1/16 of an inch, but they're just as strong as typical steel that's 1/16 inch. Let's keep reading. 300.4E was also revised. Wiring of boxes in or under metal corrugated roof decking. Cables, raceways, and boxes in concealed or exposed locations under metal corrugated sheet roof decking must be at least 1.5 inches from the decking. Now, this was added, I think, back in the 2011 code, and for good reason. We can see these roof decking screws that just barely miss the EMT. One I'm circling, and then we've got one over here. Those roof decking screws are, they're a good 6-8 inches long. They're self-drilling, self-tapping. They are nasty, nasty screws, and they will go right through a conduit. So we added this language back in the 2011 code, and I think for good reason. We also added language saying wiring's not allowed in the concealed locations inside of the roof either. So yeah, we can't be directly below the roof decking, and we also can't be directly above the roof decking, and then they put the insulation on and the roofing material and they screw right through the conduit once again. So it makes sense. If the conduits in this picture are susceptible to nails and screws, certainly these raceways up here would be as well. And in fact, there's even an informational note that they added way back to clarify why we're doing this. And it says, listen, this ensures that screws that are used for roofing material do not damage the wiring system during the initial installation or when the roof is replaced. Perfect. So what if I get there after the roofing contractor has already laid the roof? Can I still put raceways up inside the roof decking? No, because what happens when it gets re-roofed? And that's what the informational note kind of reminds us of. This photograph here is a great reminder of why this section exists. Not only did the roofing screw go right through the MC cable, but it also went right through the one-hole strap and the MC cable. Just a grim reminder of how powerful these screws really are. They will drill right through your conduit. However, if you're using rigid metal conduit or IMC conduit, you don't have to follow this requirement because the product is thick enough that it will stop one of those roofing screws. So rigid metal conduit or IMC conduit does not require this clearance if malleable iron fittings and boxes are used. So we're clarifying if we were using aluminum fittings, for example, well, that wouldn't be allowed because aluminum, of course, is not nearly as strong as steel. So I don't know that anybody is really taking advantage of this exception. up inside the roof deck trying to twist rigid metal conduit and threaded couplings, I'm not sure that it's really worth pursuing this exception. But the code does recognize that the product is strong enough that we should be able to do it if we choose to do it. Now, the second exception was added for the 2023, and I'm really happy to see this. It says, look, this requirement does not apply if the decking is beneath 2 inches or more of concrete. Look, the informational note said, this rule is there to make sure that roofing screws don't hit your raceways or your cables. So what if I don't have a roof above the metal corrugated sheet roof decking? Because the metal corrugated roof decking, that's not saying necessarily that it's on a roof. That's just what the product is called. You can take that off the roof and put it in your front yard and point at it and say, hey, that's still roof decking. So the fact that we say roof decking in the title doesn't necessarily clarify where this rule does and does not apply. The informational note clarified. It said, listen, we're trying to protect nails and screws from the deck, so why would I have to protect the cables and the raceways that are underneath 2 inches of concrete? Well, there's no reason to, and now the code specifically says you don't have to do it. So if you've got a 10-story building, you probably only need to worry about this requirement for the 10th floor, not floors 1 through 9. So do we have a violation in this photograph? No, not if there's 2 inches of concrete above it. So nice clarification. The other thing that changed here is in 300.4G for insulated fittings. Now, I have mixed feelings about this. I think it makes a lot of sense why the code says what it says and why it was changed to say what it says. My mixed feelings come from the fact that I spent a good portion of my career as an inspector, and one of the things that I try to be really careful of in the code is whether or not a code requirement is enforceable. So let's take a look at what this says, and we'll kind of look at the issue that I have with it. It says raceways with circuit conductors 4 gauge or larger must have one of the following installed prior to installing the conductors in order to protect the conductor insulation. All right, so let's just look really quick at one of the items. The most obvious one would be an identified fitting with a smoothly insulated surface. So one of these plastic bushings. All right, so let's go back and reread it with this in mind. If I have circuit conductors 4 gauge or larger, then you have to have a plastic bushing or something else installed prior to installing the conductors in order to protect their insulation. So here in the picture, wonderful example of why this code rule exists. You have to install a plastic bushing or something to protect the conductors from the sharp edges of the raceway and also to protect the raceway itself from the process of pulling the conductors. So you have to do this before you pull the wires. If you install a protective bushing after the wires are already installed, you're shutting the barn door after the horse is already gone, right? The issue that we're trying to address is only there. The risk that we're trying to address, the hazard, only exists during the process of installation. So there's no reason to pull the wires through and then add a plastic bushing. Now here's the problem I have. Put on your inspector hat for a minute. You walk up to the job and you see this installation right here. And you write them up and you say, hey, you got to have a plastic bushing. And you have to install it before you pull the wires. And the guy says, well, the wires are already here. Okay, well, what's the next part of that conversation? You going to make them rip the wires out? Then put the plastic bushing on and then re-pull the same wires? So subject them to the potential of damage twice instead of once? Or are you going to make them throw the wires away and say, hey, you gotta toss those because they could have become damaged and now you got to buy new wires to pull in after you install the bushing? Look, I think the idea is sound. Yes, we need to have it installed before you pull the wires. Otherwise, there's no point. But how do you enforce it? This is a tricky rule. This is one of those things where as an inspector, you just kind of hope you never have to write it up. But I got to be honest, I used to write this up all the time. This is a really common violation. It's been in the code for a long time, but people just don't know about it. So what are your options? Option one, you can use an identified fitting with a smoothly rounded insulating surface like we have here in the picture. That's certainly the most obvious way of solving it, and probably the most common way of solving it. Item 2, you could use a listed metal fitting with smoothly rounded edges. So a chase nipple like this, believe it or not, until the 2020 code, you couldn't use these for conductors 4 gauge or larger because it didn't specifically talk about it. It said you had to have a smoothly rounded insulating surface. Well, you're going to have a plastic bushing on the threaded side, certainly. But what about on the non-threaded side? That's perfectly smooth. There's no reason why I would need to provide any extra protection on that side of the fitting. And now, 2020 and 2023, we don't have to. Option 3. Separation from the fitting or raceway with an identified insulating material that's secured in place. All right, so usually when you see this type of product, it comes as a fitting like this and the insulating material is already installed. I'm led to believe, don't quote me on this, but I'm pretty certain that you can buy this as an aftermarket component and you can put it into your fitting. And if that's the case, well then cool, that would meet item number 3. Option 4. Threaded hubs or bosses that are an integral part of the enclosure or raceway and provide a smoothly rounded or flared entry for the conductors. All right, so here we've got our hub on the bottom. We thread our conduit into it, smoothly rounded, good to go. That would be another option. Certainly you're not going to put a plastic bushing on that. It goes on to say that fittings made of insulating material can be used to satisfy this requirement, but they're not allowed for mechanically securing the raceway to the enclosure. All right, so yes, you can use a plastic bushing to satisfy the protection requirement, but you still have to have a lock nut. That's all this rule is trying to say, which makes a lot of sense in my opinion. The last sentence in this section is kind of funny. It's one that I never really thought about until I really sat down and read it. It says the fitting or material must have a temperature rating that's not less than the conductor's insulation rating. I never really thought to look at a temperature rating on a plastic bushing like this, but most everything has a temperature rating. So this thing is rated 105 degrees C, so we're going to be in the clear putting that in. Probably need to make some changes in the 2026. This rule probably ought to say that the fitting must have a temperature rating not less than the operating temperature of the conductor. What if I'm installing 90 degree C rated conductors, but I'm terminating them at the 75 degree column? Well, probably ought to be able to use a 75 degree rated fitting. So maybe some work to be had on this section, but I think we both know the real reason that I'm showing this photograph. It's not necessarily because of temperature rating. It's because it's kind of designed to be installed after the wires are already in place. Is this product a code violation? No, it's not. Is it a code violation to put this on after the wires have been pulled? Yes, it is. And I think you could make that argument in previous versions of the code too. 300.18 says that raceways have to be installed as a complete system before you pull the wires in. Does that include the plastic bushing? In my opinion, yes, and I think it always has. But this section makes it clear now. So there you have it. Lots of things to talk about in 300.4. We'll see you on the next video.